don't have to worry about nothing.
Good morning, good afternoon, good evening, whatever the case may be. We are back and better than ever, and we do not have to worry about nothing indeed, because we are doing mathematics, the greatest academic subject of them all. And today we're talking about binary operations. So let's get to it, shall we? Okay. This is just a bit of a summary of what a binary operation is. I am not going to read it to you. It is there for you to pause and take a look at if you want. Let's just go here. An example of subtraction on the set of natural numbers is 5 minus 7 equals negative 2. In this latter case, the result does not belong to the set of natural numbers. If this happens for any particular binary operation on a set, we say that the set is not closed under that operation. So I just wanted to read that to you because it seems a little confusing right now, but as we go through the example, we're going to talk about whether things are closed or not closed depending on the operation. So let's get to it, shall we? First of all, let's say that we have a binary operation indicated by this asterisk right here on the set of integers, and it's defined by a star b equals a plus 2b minus 3. So find 3 star 5. Okay, well, I'm going to rewrite it just so it's right here in front of us. A star b is equal to a plus 2b minus 3. So 3 star 5, it's just substitution, and you might think this is so easy. Well, it is, but you have to make sure you understand the substitution, because what you're going to be using for substitution gets a little confusing here in just a little bit. So this would turn into 3 plus 2 times 5 minus 3, and I believe that is going to be equal to 10. So B, 3 star 0, the temptation might be to say, hey, it's equal to 0. No, it's equal to 3. Actually, it is going to be 0. Isn't there egg on my face? 3 plus 2 times 0 minus 3. It only ends up being 0 just because of this minus 3. It's not going to be the case all the time. So that is equal to 0. As you'll see here for C, 0 star 3, well, that is equal to 0 plus 2 times 3 minus 3, which I believe is equal to 3. And then finally, we have negative 5 star 0, which is not going to end up being 0 because of the binary operation which defines it. So this is going to be negative 5 plus 2 times 0 minus 3, which turns out to be negative 8. Easy peasy pumpkin pie. So let's talk about closure. I mentioned that in the opening. A set S is said to be closed under the binary operation star if A star B is an element of the set S for all A, B, and S. So in other words, whatever operation that we perform with A and B, the result or the answer has to be in the set S for every value of A and B in order for the set to be closed. If not, then the set is not closed. So let's take a look at this. So A, which of the following binary operations are closed on Z? Well, you have to understand that Z is, boys and girls, that is the set of integers, okay? And a lot of this, you just have to really think about it or come up with one counterexample, because remember, it must be true for all values of A and B. So that means that this, for all integers, we have to end up with an integer in order for the set to be closed. So what you try and do is come up with a counterexample where it's not an integer, or try and think of it. How about A equal to 2? Let's say A equals 2, B equals 3. They're both integers, so we have satisfied this part. It's a set of integers. So a star b would be equal to 2 plus 3 over 3 squared. There's lots of different counterexamples here. I think you can see that this is 5 over 9, which is not an element of the set of integers. Therefore, this implies, this little arrow right here stands for implies, by the way. I use it quite a bit, as do other mathematicians. Implies that the binary operation is not closed. So all you need is one counterexample, because it has to work for everything. Has to work for everything. So let's take a look at B. What about a star b equals 2 to the a plus b? So a star b equals 2 to the a plus b. So you might think, oh, well, if I raise 2 as an integer, and if I raise a sum of integers, or if I raise 2 to the sum of integers, I'm going to get an integer. Well, that might be true for the positives, but let's say, I don't know, let's say that a is equal to -2 and b is equal to 0. Let's try it out then. Well, then a star b would be equal to 2 to the -2 plus 0, which is 2 to the -2, which is 1/4, which is not an element of the set of integers. So again, it is not closed. The binary operation is not closed. Okay. So here we go. A star b is equal to a plus b minus 3ab. Okay. So let's think about what's happening here. I'm taking integers, I'm adding them, and then I am subtracting the product. Okay. There is no way with positive or negative or 0 to get anything but an integer. I'm sorry, with positive or negative integers or 0 to get anything but an integer. There is no counterexample that we can come up with. So all of these, all are going to be an element of the set of integers. So therefore, the binary operation is closed, because no matter what integer I replace a and b with, I will end up with an integer under this operation. Okay? Okay. All right, so we will end it with that. This is part 1. Get ready for part 2. We'll go out with Ellie, see how she's doing.
They're gonna see us from outer space.
Outer space,
Outer
baby.
space,
And
light it
I
up.
am...
We're the stars of the human race. Human race. Sing along.